problem. I'm trying to figure out the integral of ln x dx. I can't just use a power rule. It's not like to the power 1, bring it down. No, that's not. But remember we did this. Remember we said the integral of u dv is equal to uv minus the integral of v du. Remember we did integration by parts. One's a u, one's a dv. One I'm going to do the derivative, one I'm going to do the antiderivative. There's two functions here. It's really 1 times ln x. So if I know that u is, I know the derivative of ln x. So if I say u is ln x, that means du is 1 over x. Well, dx. Which means the other one, the dv, is really 1 dx. 1 dx, which means v, well, the antiderivative of 1 is just 1x. Okay, so hang on. So let's do this. So it's uv, it's these two, so it's going to be ln x times x minus the integral of v du. X times 1 over x dx. Now that's kind of nice. This turns out to be x ln x minus the integral of 1 dx. The integral of 1, hang on, that's just 1x. So this is minus x. So hang on, this becomes x ln x minus x. Well, plus a c. I should probably throw in the absolute values. I'm allowed to know that. I'm allowed to memorize that. So the antiderivative of ln x turns out to be x ln x minus x plus c. Now we actually found that before on the last test. Yeah, because when we did the derivative of that. Okay, so let's do this again. Ln of x squared. This is number 4. We're going to try it 2 different ways. Now, hey, I want to bring this 2 down front. No. If it was like this, if it was ln of x squared, yes, that can come down, but I can't do that here. So this is one function. Okay, so I could make this ln x and ln x. Okay, so let's do this. U dv. One of them is going to be ln x. The other one's going to be ln x. Well, ln x dx. So the antiderivative and the derivative, let's see. Du is 1 over x dx. And the antiderivative of v is just, of dv is, this is going to be, we just did this one, x ln x minus x. Okay, so here we go. uv, so it's going to be ln x times x ln x minus x, whoa, x ln x minus x, minus the integral of v du. So x ln x minus x times 1 over x dx. Hang on, this is all going to simplify, isn't it? Hang on, let's see, what do we got? We get x times, so x times ln of x squared minus x ln x minus, this becomes the integral of ln x minus 1 dx. We just did this one. Okay, so hang on, so what do we got? X ln of x squared minus x ln x minus, the integral of ln x is x ln x minus x. I'm also going minus minus, so that's going to be plus, plus the integral of 1, which is plus x. Plus c on the, okay, so hang on, let's simplify this down. X times ln squared, okay, x ln of x squared minus x ln x minus, so minus 2 x ln x's, minus minus is plus x, that's plus 2x. Well, plus a c. Yikes, that's a beast. Let's do it again. Instead of saying ln x and ln x, what if we did our old trick where we said one of them is going to be 1? Remember? U and dv. Okay, so I don't know the antiderivative of this thing, but I do know that if I do ln of x squared, the derivative, 2 comes down to this to the power of 1. So it's going to be 2 ln x to the power of 1 times the derivative of the inside, which is 1 over x dx. There we go. Okay, so if dv is just going to be 1 dx, that means that v is just x. Okay, so here we go. Let's do this again. uv, so it's going to be x times ln of x squared minus the integral of v du. X to, oh, the x's are going to cancel. This becomes 2 ln x over x times x dx. I know those are going to cancel. This just becomes 2 times the integral of, I recognize this, x ln x squared minus 2 times the integral of ln x is really x ln x minus x. Well, plus c. Guess what? Let's expand this all out. We're going to get the exact same answers we had up here, isn't it? This becomes x times ln x squared minus 2x ln x plus 2x plus c. I should probably now put those back in there. It's the same answer either way.